Hi guys, so we are going to be right back at it here, and what we're going to do is we're going to look at the word problems, or rather we're going to look at the exponential growth and decay problems. So most of the applications will use the following formulas. A equals A naught b to the power t over p, or A at t if we want it in functional notation, equals A naught b to the power t over p. Now, importantly, what's going on right here is A at t represents the final amount. And once we get to the actual word problems on these, it'll start to become a bit more clear exactly what's going on, but we'll get there when we get there. The next thing that we have is A naught is the initial amount. Now this will actually, when we're looking at it graphically, this will change the y-intercept. And we'll talk a bit more about that when we talk about transformations, but it's just important to note that if you're going to look at this graphically, the y-intercept will change. B is the factor of growth when b is greater than 1, or it's a factor of decay when it's between 0 and 1. And we will get to that in a bit. T is the time elapsed, and P is the period of growth or decay. Again, once we get to the questions, we'll be able to clear this up a little bit. So let's dive in. Now, we again just have the equations being put in different ways. Once I get to the examples, this will make a bit more sense what exactly is going on here. So, starting off, a biologist studying a colony of bacteria determines that a certain culture grows exponentially such that the bacteria doubles every 4 days. If initially the biologist has 1,200 bacteria present, how many days does it take before 100,000 bacteria are present? Well, let's look and let's start to build our formula here. So, going back, what we have is we have A equals A naught B to the T over P. So, I go A equals A naught multiplied by B to the power T over P. My initial value is 1,200. So I put 1,200 in for the A naught. Sorry about that, I almost wrote it on the wrong side there. From here, we want to know how many days it takes before we have 100,000. So 100,000 will end up being what I get on my left-hand side. Now we see that the bacteria doubles every 4 days. So if it doubles, that means that it's going to be multiplied by 2. And it's multiplied by 2 every 4 days. So my power right here is just going to be t over 4. Now why is it t over 4, you may ask? Well, if we think about it, after 4 days it happens once. So when t equals 4, it should happen once, and 4 divided by 4 is 1. After 8 days it should happen twice. 8 divided by 4 is 2. After 12 days, 3 times, and so on and so forth. Now, when we're looking at this, as it stands right now, we haven't really gone through the algebraic way of handling this, and we may have to involve logarithms and some other stuff that you guys don't quite have in your wheelhouse yet. So, as it stands right now, the way that we're going to handle this is we're just going to take this and we're going to punch it into your graphing calculators, and that's how we're going to handle most of these. So what I'm going to do is I'm going to look at my y1 and I'm going to look at what my y2 is. So in this case we have our y1 equals 100,000 and our y2 equals 1,200 all multiplied by 2 to the power, and I'm going to put it in as being x over 4. Now very, very importantly, when you are putting this in, you have to remember to put that bracket around the x over 4 if you have one of the older models of the calculator. Otherwise, you may not get the right answer on that, and that's a common reason why. So, the next thing to bring up is my window range. You will notice that I'm putting in a y value of 100,000. Since I'm putting in a y value of 100,000, I want to put my y max as something bigger, so I'm going to use about 120,000. Also, for my x value, well, we don't know how many days it's going to take, but we're dividing them by 4. So we're going to put a bigger number. I'm going to say 50 or 100 in there to start. And then once we get the answer, we'll get a better idea of what the value is. So I put those two values in. I use my second trace, and then I go for my intersect, enter, 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 and this will give me approximately 25.5. So when we put this in, what we're going to do is you'll get a graph, and you'll get that straight line which represents the y1, and you'll get that exponential curve. Then you're looking for that intersection point right there. Now doing this, we get approximately 25.5. So that means that the time, and it's just I'm going to answer with words here, it will take approximately 25.5 days. Now what we're going to do is we're going to keep on rolling on. Again, I think if you guys want to give these a try, you can just pause this, but we're going to keep on going. Actually, I'm going to stop there.